did make it to a movie this weekend. I didn't go the first weekend, but last weekend we went and saw The Unbreakable Boy. Saw it Saturday this week. The Unbreakable Boy. Tremendous movie. Very, very good. I was kind of blown away. I went to see it because my daughter wanted to see it, and so supposed to. You see the trailer. That's about this young boy with autism and has this genetic disorder that makes his bones pretty brittle, and he's like 13 and going to school and really, really, really something. And so I'm like, oh, okay, that'll be interesting. And it was great. And it really was more about the father than the boy. The boy had a brother as well, but the whole family dynamic, really, really good. Squishy Bones. Sorry, I don't get the reference for Squishy Bones.
It's from a Danny Gonzalez video. He's on YouTube. He's pretty funny.
Okay, yeah, I guess I'm not familiar with that one, but no, the movie's really good. If you get a chance to go see The Unbreakable Boy, it's worth your time. It was very. I cried multiple times. Didn't expect that. A lot of it was funny too. It was really good. Yeah, it's a real story too. It's a family over in Oklahoma City. And so this is from a book written by the father about all the challenges and stuff. And of course now, it's about 15 years ago is what the story's based on. Those kids are grown now and everything, but really, really good story. So, all right. Well, it is 7:19. Just want to say, I like to talk about these things sometimes. We struggle sometimes with self-confidence and feeling good about ourselves and all kinds of things like that. And that doesn't come from people giving us compliments or people giving us insults or anything like that. That doesn't do it. What makes us feel good about ourselves and gives us self-confidence and makes us feel like a good person is the things that we do. And if we do things that we admire and we do things that we respect, we admire and respect ourselves. That's kind of how it works. And that's always been true. I mean, people insult us, we get upset and all stuff, but we know truly ourselves how good of a person we are and what we do. And I think a lot of you guys really built your self-confidence and built your self-esteem last week, because I had a lot of people turning in programs and emailing me during the week saying, Mr. Brock, I'm trying to do this. How do I do this? Or I'm getting an error here. What I can't figure it out. I had a lot of that last week during the snow week when you guys had no assignments. Some of you are catching up on programs from the past. And I said, man, that's a great thing. So when you get back to school, you've got those programs turned in, you feel so much better. It's a fresh start. You're ready to roll. You're not dragging several weeks ago's assignments with you. So just want to say proud of you guys that were turning those in and getting caught up on things, because that was a great use of your snow week, because no new assignments, no new responsibilities. Might as well get caught up on the old stuff that we didn't do when it was supposed to be done. So great job for those of you who got things turned in last week and made great progress on that. And if you haven't got great progress, you still got time. Semester's not over. Get on top of it. So, all right, let's get up on the screen what we're looking at this week. We are not writing a program this week. We just have a 5-question quiz. So this is still a great week if you're behind on programs to take advantage of that and get your program turned in, because the 5-question quiz doesn't take very long. So take some time and get caught up if you're still behind. So, okay, foundations of programming. Let's look at our grade screen. We can see we're completely done with the first unit. Module 4 should be turned in. Last one was due the week before the snow. So hopefully that's turned in. You can see that I didn't get it turned in until the snow week, but I got it turned in last week. So that's good. Made use of my time to get caught up on a lot of things too. So this week we're looking at starting our number systems, codes and objects module. So we're going to start. This is only 4 lessons, so this is a little shorter. Number systems, and this is going to take us up till spring break. Basically, you see, we got 4 weeks till spring break. So let's look at 5.01. Close Module 4 folder. Open Module 5 folder. Number systems. Types of numbers. How many teaspoons are in a mile? Anybody know? You know that right off the top of your head? What's your height in gallons? How many gallons tall are you? Just, well, this is not typically how you measure distance or height, right? That's not, but you could probably figure out a way to convert the numbers if you had to. You'd come up with some kind of system, some kind of method. You could do that. So in programming, there's quite a few different types of numbers. Some are used to represent symbols, some used in calculations, some used to represent colors or memory locations. So in this lesson, we're going to learn how to describe how different number systems are used to represent data. I could have worn my hexadecimal shirt today. I didn't. It's packed away. I'm not back in my house, so I didn't have it. But our world runs on two things: language and mathematics. Both of them are part of everyday life. We use language to communicate, and we use math to pretty much do everything else. Think about it. Computers are nothing but math. If you're an architect, you need the words to describe what you're doing, and you need the numbers to make it work. If you're a musician, words come in handy for lyrics, but numbers actually arrange the music and set the tempo. In programming, the type of number used depends on the type of data. Each number system has a different base, which is the number of different digits it uses. For example, we use the decimal number system, which is base 10. That's what our society is built on. We use 10 digits, 0 through 9. But let's look at some different number systems, how they're used. So the decimal system, base 10, is probably the most familiar system to humans. Decimals are, 10 digits, 0 to 9. Money uses the decimal system. All amounts used are 10-digit system, $1.50. There's also the binary system, which is what computers run on. It's base 2. It only uses 2 digits, 0 and 1. The combination of zeros and ones can be converted into other numbers or even words. So you can use the binary system to write other types of numbers or words. 00110001, 00110010, 00110011. That's 123 in binary. But just using zeros and ones. Then there's base 16, the hexadecimal system. Base 16. Hexadecimal numbers are the most common in the computer world, most often used in relation with the colors and memory locations. They're based on 16-digit. Hexadecimal is base 16. So it uses 0 through 9 plus A through F. So you may have seen some hexadecimal code and not even realized it, but that's what you're looking at. 0 through 9, A through F. All colors have a hexadecimal code that computers use. The numbers symbol followed by a string of numbers and letters like hashtag FFD700 is the hexadecimal code for the color gold. So that's the assigned hexadecimal for gold right there. So hexadecimal is used throughout computing. All right, converting systems. Things aren't always hashtag 0000 and hashtag FFFFF. There's 10 types of people in the world. Well, that's what we see in these signs, right? There are 10 types of people. 01, those who understand binary. 10, those who don't. This is a computer joke because this is actually hexadecimal for 2. 10 is 2. So this is 1 and this is 2. There are 2 types of people in the world. 1, those who understand binary. 2, those that don't. I've seen t-shirts like this, memes, and people read that as decimal rather than the binary. Now, the great thing about different number systems, you can convert one from the other. If you have one type of data in decimal form, but you need to use a system that reads like binary, like a computer, you can do that. So in the decimal number system, each place value is a power of 10, right? The ones column is 10 to the power of 1. The hundreds column is 10 to the power of 2, so on. Same is true for binary. So it's easy way to convert is to use an online calculator. There's also a nifty way to do it on your own without a computer. So get a marker. You're going to draw on your fingers. That's how it works. So here's a quick way and easy to convert binary numbers to decimal. Hold up your non-writing hand. So if you're right-handed, hold up your left hand. Starting at the leftmost finger, which if you're right-handed, that would be your thumb on the left. Write the decimal numbers 16, 8, 4, 2, and 1. That's one number on each finger. These numbers are powers of 2. That's 2 to the first power, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. And we'll be converting to binary. So think of each individual finger as a binary number. When a finger is raised, it represents a 1 in binary. And when it's down, it's a 0. So if you close your fist, you're showing 0 fingers. That would be 0, 0, 0, 0, 0, and that's 0 in binary. If you lift all your fingers, that's 11,100. Oh, that's 11111. We think, in decimal, it'd be 11,111, right? It's all ones. But in binary, you just add the numbers together. You got a 1 plus a 2 plus a 4 plus an 8 plus a 16. That's 31 in binary. That's the same as 11111. So you can use that system to do different numbers up here. This is 31. This here is 30 because you got 16, 8, 4, and 2. This is the number 6. This is the number 3 because you got the 1 and the 2 out. You got the number 1 right there. Can you come up with the binary number for 12? Yeah, you would hold up the 8 and the 4, right? The 8 and the 4 would give you a 12. So you hold up the middle and left finger, depending on which hand you're using. So yeah, hold up the finger with the number 8 and finger number 4, and that's 12. Although that would be 0, 1, 1, 0, 0 in binary. So that's kind of how you read binary. So binary to hexadecimal. The hexadecimal system is comprised of 16 symbols, 0 through 9 and A through F. It's base 16, which makes it ideal to use as a way to represent a binary number, but with a lot fewer digits. Because a binary number is considered a bit, and 4 bits can be represented with 1 hexadecimal number. Let's look at the breakdown. So if we have this binary number right here, we have 11000111. Well, the 0111, that's a 1, a 2, and a 4, so that's 7. Over here we have a 4 and an 8, so that's 12. But in hexadecimal, 12 is C because you use 0 through 9, 10 is A, 11 is B, 12 is C. So we can just write C7 in hexadecimal, and that represents the same as 11000111. It's a shortcut, C7. Takes a lot less memory space, and in times past, memory was much, much, much more expensive than it is today. And so they found different ways to save memory space in computing, and this is one by using hexadecimal numbers. Much shorter to write. So it says, take a look at the binary and hexadecimal numbers for the value of 15. Which would you rather type out? Well, here's binary, 11111. Hexadecimal, you just put an F. Just an F. So here's a comparison chart. Here's the numbers 0 through 15. In decimal, in binary, and in hexadecimal. So both decimal and hexadecimal are a lot shorter than binary. Hexadecimal just uses 1 digit all the way to 15. We got to use 2 digits once we get to 10 in decimal, but 4 digits all the time in binary. All right, let's look at our last page here. Converting in Python. Now you understand the different number systems. You can probably tell they take a while to figure out in your head, just because, we don't think in hexadecimal. We don't think in binary. It's another area where Python can save the day. So we got these different commands, bin parentheses and hex parentheses. Python will do conversions for you. Look at this simple code here. Age equals 17. That's in decimal. That's a number we recognize. If we said binary age equals binary of whatever age equals, and since age equals 17, it'll give us the binary equivalent of 17. And then we can print that, print binary age. So let's look at these guided activities to see some of these sample programs in doing this. So number systems. So hashtag, this is just a comment letting us know what this portion of code does. Assign a decimal number to D. So we assign the number 7 to the variable D. And then we print the decimal value is. And we'll print D as a string. Remember, we're going to use that str when we're printing letters and numbers together. Now we're going to convert it to a binary number using the binary command. B equals the binary of the decimal number. Print the binary value as this. All right, so let's run the program to see what it looks like. Decimal value is 7. The binary value. Now, this is what happens in Buzz. in Python, I'm sorry, not Buzz, Python, it will put a 0B in front of the number. Just to let you know, hey, pay attention, this is not a decimal number. When you look at this, this is not 111. This is the binary number 111, which is 7. So that's how it lets you know when it's displaying a binary number, not to treat it like a decimal. A little code it adds out there. All right, let's change this to 27, and let's see what it does now. Hey, this is a binary number. 11011 is 27. About 131. 1000011. Get that little 0B out front. So the 0B is always going to be there if it's a binary number, just so we understand, don't treat this like a decimal. This is not 10 million. This is binary. All right, let's look at the next slide. Find a decimal number, D equals 7, convert to a binary, print the binary, everything looks the same. Oh, except for now we've added more code. Going the other direction, convert a binary number to a decimal number. Hashtag integer. You put the number and what the base is. So if we say the decimal number is, I want it to be an integer. Here's the number, which is going to be whatever it was binary. It says, and this is base 2. So I tell it, hey, this binary number, this is a base 2 number. Please convert it back to an integer so I can read it as a decimal. So let's run this program. Binary value is 0B111. Decimal value is 7. So you notice we didn't print it up here the first time. We converted it and then printed it. So we go back to that 131 we were playing with. 100000011. The decimal value is 131. You can use this command to convert numbers back to decimal. Oh, thank you so much. I don't have to learn hexadecimal. I don't have to learn like base 8 numbers. I don't have to learn any other base. I can convert it if I need to know what the number is right here in Python using the integer command with a comma. There's the number. And, you know, we could just type in the number, integer 100000011. Say, hey, tell me what this number is. It's in binary. Convert it. Oh, can't convert non-string with explicit base. Oh, I did something wrong there. It wants it to be an actual integer, a variable. So when we assign it to a variable, it works. Okay, so there's something to learn in there. All right, let's convert hexadecimal. So we assign 156 as the decimal number, and we print that. Then we use the hex command. They take whatever this decimal number is and convert it to a hexadecimal number. So the hexadecimal value is, and notice we don't have to use string with that. It's not a decimal number. It'll print this because it has letters and numbers. Convert a hexadecimal back to a decimal, use the same command. Take this hexadecimal number, it's base 16, convert it back to an integer. So let's print this. 156 in hexadecimal, it's 9C. Now notice, instead of a 0B now, because the 0B said, hey, this is a binary number. For hexadecimal, it uses a 0X, not 0H. It's 0X. Hey, this is a hexadecimal number. Pay attention. I'm not giving you a decimal number. I'm giving you a hexadecimal number. A flag, attention. You bet, Liliana. So let's change the number, see what else it does. Let's say it's 2,156. What does that look like as a hex? This was just 2 digits here. 2,156 took 86C. 3 digits. Still shorter than the decimal version. Pretty nice. Because it's base 16. It doesn't take as many characters. All right. Let's And yeah, there's an actual C in our number. So in hexadecimal, it uses letters as numbers. You thought just mathematics was weird, right? All right, user input. B equals 0B plus, enter a binary number. Oh, so we're going to create a binary number and we're going to add a 0B in front of it. So Python will know this is a binary number. I like this. This is very clever. Enter the binary number and add the 0B to the front of it using this concatenation. So it'll be saved in our variable as 0B and then a bunch of ones and zeros. And it'll tell us what it is, your binary number is, and it'll print it. Notice again, we don't have to have the string if we're not printing a decimal number. And then we're going to convert it to a decimal to see what that number is. We may not even know what the binary number is, but this program right here is built to do it for us. This is a wonderful program. So the way it works, the integer command, you have to put the number and then the base that it is. So I want it to be an integer. Right now, it's whatever we typed in with the 0B on the front, and it's base 2. Please convert it and tell me what the decimal is. So let's run the program. What is it? Let's say 0 1 1 0 1 0 0 1 1 1 1 1 1 0 1 1 0 1 1 0 1. There, I just gave a number. I have no idea what it is. Let's find out. That's 434,029. But in binary, it's all those zeros and ones. But this one is 2 to the 0 power. This is 2 to the first power. This is 2 squared, 2 third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh, 2 to the eighth. So this is like 2 to the 20th power or something. You know, it's a really big number. And it's 434,000. We just had a simple one, 1011. That's 11, right? There's a 1, a 2. There's not a 4, but there's an 8. So an 8 plus 2 plus 1 is 11. Nice. And that 0B was added to it in this statement on line 6. Put a 0B in front of whatever I type. So Python will know this is a binary number. All right, our last slide here. All right, define main, print table headings. So we're going to print a little chart, number systems chart of decimal, binary, and hexadecimal. And then we're going to print the table. So we're using a loop, and the loop goes from 0 to 15. It stops when it hits 16. It'll jump out of the loop when it hits 16. So 0 to 15. So first, it's going to print the binary number. Then it's going to print the hexadecimal number. Well, it's going to convert it. I mean, it's not going to print it yet. It's going to say, okay, the binary equivalent is whatever the binary of that number is. The hexadecimal equivalent is whatever the hexadecimal number is. Here's our print statement. We're going to put some spaces first because we want them to line up underneath these headings. To put some spaces, then print the decimal number, print some more spaces, print the binary number, print some more spaces, print the hexadecimal number. And here's where we made ourselves a little conversion chart. There it is from 0 to 15. Binary is 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, all the way down to 1, 1, 1, 1, 1. All right. And the hexadecimal goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So this little program on slide 5 gives us a little conversion chart, which we can make it bigger if we want. We just have to make the loop bigger. If I want it to go to 100, this will go from 0 to 99 now. When I run that, now here's a conversion chart that goes all the way to 99. So if I want to know what 99 is in binary, it's 11000011, or it's 63 in hexadecimal. Pretty snazzy. All right. So that is the end of our lesson. Let's see what our questions are going to be about. So let's go to the assignment that goes with it. Binary system uses 2 digits, true or false? Which the following is an example of a binary number. Okay, so these aren't bad. What's the purpose of using bin, parentheses, and hex, parentheses functions? What do they do? Read the code. Which is the output? What would you expect? This one, now remember, yours may be different. This is day 12, the binary day. It's going to convert it to a binary number, print binary day. So which one of these prints the number properly as a binary number? Is it 0B, 0D, 0P, 0X with the 1100? Remember which one is binary? Right? Yeah, binary is the B. This is the hexadecimal right there, the 0X. And these I don't even know. That's not systems we played with. Read this code. Skittles 255. Hexadecimal Skittles equals hex Skittles. Print hexadecimal Skittles. What's that going to be? A 0B, 0X, 0Y, 0Z. It's an X, right? X is how it prints a hexadecimal number. And the number's FF. 255 is FF. So, all right, that's not going to be bad. Save and exit. That's it, 5 questions. So if you are behind on any past week's programs, didn't get everything turned in during the snow week, oh, my golly, jump on it this week, because next week I'm sure we'll have a program that's how it works basically every other week, right? And then sometimes the unit test is not a test; it's a program, like we ran into last unit. We had so. If you need help with anything, this is a B week Friday. Tomorrow is the ACT, so I know juniors will be taking ACT tomorrow. Everybody else will be having classes. So if you're not a junior, you should have your normal classes for the most part, unless your teacher happens to be giving the ACT, and then check with your teacher to see what they're doing. Otherwise, I'll be here Wednesday, since Friday's a B day. So if you need trouble, if you're having trouble with your program, if you need help, email me or come Wednesday. If you're behind on programs, you probably need to be here on Wednesday. Your grade's probably below 70% automatically because programs count for 100 points. This week is just 25 points. Big difference. Whew. So, all right. I'll see you guys Wednesday or next Monday. Have a great week, folks. Welcome back.